Right. And you can tell me another question. Okay. One by 30 strip of squares. Yeah. Okay. So, okay. Okay. Right. So, so how do you do it? Do you know? Hmm. Hmm. Right. Correct. Uh, right. Yes. Yes. But then that's right. But then there will be a lot of cases because um, 30 30 cases. There might be some pattern, but I don't know. Okay. Uh-huh. Hmm. Hmm. Right. So let me use right hand. And then this gives you right. So that is n plus r minus 1. Choose r. N plus r minus 1. Choose r or r minus. Okay. So no. 29. Right. That's right. And will this 29 remain the same? Yes. Oh, then it's very easy. So, uh, what is the answer? 2 power 21, right? Yeah. Oh, okay, okay. Right. Okay. Yes, yes, yeah, yes. M by N. So M by N. Great. Right. Yeah. Mm-hmm. Mm-hmm. So, um, So you have to pick two pairs of numbers. Mhm. That is given. I'm saying about the vertices. So like this vertex and this vertex. Then the rectangle is determined. And the, hmm. Uh, well, yes, m plus 1 choose 2. Okay, then, right, that's right. And mhm. Then you subtract these rectangles and these things. Hmm. Yeah. Hmm. Uh, hmm. P units. So are you including this P also? Yeah, P. Okay, P minus 1 units. Okay, right. Yeah, and then you have to just do some inclusion exclusion. So what does it do? Okay, okay. So this is Q minus 1. No, yes. Okay, Q minus 1. And this is, right, the other side is n minus Q. Okay, so what are the, right, right. Hmm. But hmm, what? These, okay. But no, but haven't you also counted the rectangles in this region twice? Yes, but that isn't that like inclusion exclusion. That is okay. Then, but yeah, so in a few steps you will get it. Okay. Yeah. So, but I was thinking that if you just pick the vertex A and B, then that should do it. So you have to pick A because if you pick two opposite vertices of a rectangle, then it's determined. And now this A, you have to pick. So if your rectangle has to contain the right cell, then the A has to necessarily be picked from these vertices. Otherwise, it will not contain the rectangle. Right. So for A, then we have how many choices? Right. But why P minus, why P minus 1? Why not P? Yes, so P, right? So if it is P, wait, so the length is, yeah, this is P, and this is N minus Q, or is it N minus Q uh, plus 1? No, it is N minus Q. So then it is P times N minus Q. Uh, no, 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 but it has to be here, right? It cannot be here. It is N minus Q. So there is no ambiguity. It has to be like this. So one of the vertices we have picked, and now this opposite vertex B has to be in this region, right? So then just by the same thing, uh, will it be just a product, or of course it will just be a product, right? So then it is just Q times M minus B. Yeah. Yes. And or wait, or are we doing something wrong? Will it be Q or Q minus 1? No. And this is 0 to, no, this is 1 to Q, and then this is Q plus 1 till, yeah, it is right. Okay. N minus Q plus 1, right? Uh, yes, right. You're right. It should be. Yes. Yeah, that plus 1 has to obviously be there. So mistake. Yeah. It's just like here you have length P minus 1, so you have P. So here it will be N minus Q plus 1. Because that many bit points are here, that's why the number of cells then is. Anyway, so that is fine. Yeah, but if you can check the answer, yeah, this is correct. Okay, that's good to know. Right. So this is a, I would say, more elegant way. Yeah. Yes, yes, yeah. That's how you. That's these are the things that you. And see, even in the first problem, like the very first thing it comes is that it should be a power of two. It should be a power of two, and like of course this is fine. You have shifted and so on. This is fine, but just think why it should be a power of two. Right? But right, yeah, like it visits. Right. Yes, yes. You have to think in this elegant sort of way. Okay. Yeah. And of course, there is So you have to, yes, yes, you have to balance that. You have to balance that. You have to practice that. Okay, because this is important. I mean, and even like I just saw it in no, in another way. Like there are 30, basically there are 30 numbers, and you could just put some plus signs in between, right? And you can put them in total the 30 ways. Sorry, yeah. So there are 30 numbers, just 30 dots, and then you just put plus signs, right? And how many plus signs you have to put? Well, of course, 30, because not more than 30. That's number of moves. So something like that. Okay. So in power of 2, it has to be power of. So that's why I was initially not. And also, like, you can just possibly see it by just recurrence also. But, or maybe that's not a good recurrence. Let's just see. So if there are n boxes and the an moves, and then you add an extra box, then I don't know if it's good. So um, number of ways to, but then it will depend on the previous visit. Huh. Yes, yes. So the recurrence will lead to this kind of this choosing, because it will based on the n minus one of this box where it was in there, so it will become complicated. Yeah. So recurrence will not, and so on. Yes, yes, yes. Then it will become like this, but yeah, otherwise you can see it in those ways. But should but you see, we always get the feeling that somewhere you might have felt that it's a power of, I don't know. So then if you so when that feeling comes, you have to catch on to that and take that and try to pursue that. Okay. And that we have to practice. So like whenever we solve a problem, then always there is some vague intuition comes, and in the end we see that the answer was that, but we never pursued that vague intuition. Okay, we went for the more straightforward way or the more routine way. Okay, but we have to start taking more risks. Okay, that okay, I got a bit of I got some vague flash that it should be like this. Let me try that. And obviously you may fail, but then you will learn to basically you will learn to know which kind of flash to pursue. So in the exams you'll be better prepared, because we cannot take too many risks. I cannot, okay, I cannot suddenly say that, okay, let me try this for not 1 by 30 grid, but n by n grid. Because, but that's probably not exam friendly. Okay, okay, and not during the exam, but for some problem it might be friendly. But that intuition, if it comes, then you have to trust it and take it forward. But that trust will only build if you do that thing while practicing at home. Right, that whenever you get this vague intuition, I think in this one, not like the standard way, but feels that that kind of thing should work. Then we try that. Okay, that feeling is there within us, but we don't catch it, and then maybe over time we also lose that, and it stops coming. Okay, and you see some people who do these beautiful constructions, they are actually following their heart in some, and they are not fearing it, and then they have built it over years, right? So you give them some strange problem, and they'll come up with some strange construction, but we'll be too afraid to do it. So this is in everything, right? In every sport or whatever you know. So yeah, yeah. So you have to do that. You have to be brave in yeah. So obviously, but I can understand there's an exams obviously to practice, and that practice mode tells you that no, you should just do the straightforward, but you have to balance that. Yeah, you have to find that. Okay, so let's. Uh-huh. And 1 by 2 plus. Oh, sorry. And maybe just give me a minute. Have to take a bucket. Right. Okay. 1 by 2 times 3 by 4. Yeah. Mm-hmm. Oh. Yes, these things are usually strict because it's a one inequality and there are no variations. It's 1 by 10. Okay. Oh, okay. Hmm. Um, okay. Cancel it. 3 by 4, 5 by 6 of this. 7 by 8 years. But now it looks incomplete. Now there is a feeling to complete it. But anyways, it's like whichever works. Oh, you want to show that this there's a one. Right, yes. No, yes, you can group. Okay, go on. Uh, or maybe 98 turns. Sorry, yeah, 48. Or you have also, oh, right, 48 turns. Right. Hmm. Hmm. Okay. Okay. Yeah, you can group and compare. One like here or to the left. Add or 1 times 4. What does I mean, if you take this list some initial products, yeah, then the rest we can just say. I think no. This thing. Hmm. Uh, yes, that's right. So you say that we compare few terms initially and see. Okay. Yeah, then it will remain lesser or yeah, always. So 3, 5, 7, 9, 11. This, right. So 15, 7, so that's 105. 9, so that's 145. And this. And we have, it's still 12. So 48, 8, 48, and 12. So 9, okay. 6, 30, 12, 3 is 36. And then there is 3, 6, 8. Why? Or maybe multiplication. All right. Okay. Uh, okay. Let me check something. No. It's coming like this. Yeah, and then there is another 0 for the 10. Yeah, but I don't know. It's coming to be this. 8. No, this is fine. This is fine. But the problem is that it is not 1/12. It's just 4 times this. Right. This is the because we need it to be 1/12. No, but yeah, okay, but I multiplied the 12. Not 1/6. Yeah, so this is obviously not a good practice. It will become, but after more numbers you have to multiply. In exam, if one has time, they can just put wrong enough. But hope to get. Yeah, you just try to do that. 50, 50, 51, 52. Yeah. So no, probably it will not be maybe so. And here we have 4. But then what do you get by pairing? Get it? Get this kind. I don't know. Let's. Yes, I don't know the value of log 99. I do. Oh, just minus. Hmm. Yeah, let me just check a value of log. No, I'm taking base 10. Taking base 10. Let me just check. Oh my god, what is this? So many log 10. 19. Yeah, 1.995. 1.995, right? So 1.995. 2.0. And then right this, and then we have minus of this or whatever. So we are where? Oh, oh right, right, this. Right, this is 0. Yeah, okay, good. So this is this. And then we have this thing times 50. And you would like to show that this is bigger than 1, but it is not. Right. Huh. Yeah, it is not. So it's so did you try taking log and integration and so on? Okay. Yes, we can show this. Yes, yes, that's what I'm thinking. So this three, yeah, we have to use induction. This doesn't look like a good thing. Then what do you put? Simultaneously, you should also have a lower bound which looks similar to this expression. But right, yeah, but 3 by n, then we have 3 by 50, and 3 by 50 is even less. So you don't want. I mean, both the upper and lower bound should have a similar look. Yeah, and you should follow at the same time. I don't think there should be two cases and small. Yeah, I don't know. So instead of 4 by n, yeah, okay. Let's try it. Yes. So yes, yes, better to try and know. So 2n plus 1, 2n plus 2. So has it right? So, we no, we have to check it. It is not correct for some small numbers, right? Hmm. Yeah, it's not correct. So this is not correct even for big numbers. It's strictly bigger, yes. So yes, 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 that might. Is- So here the n is 50 and hmm, yeah, but we have to, yeah, okay, it's fine. So the square root. um, okay, 2 times square root of is this even bigger than 1 by 4 and right, it is. So that is fine. And for 50, you do get 1 by 40, which is fine around. Let's try it. Right. We have to show that this thing is less than 1 by 2 times square root of n plus 1. Yes. Then the 2 cancels. So we have 2n plus 1 times square root of n plus 1. 2 times n plus 1. Is this correct? Square root of 8, which is 2.7 or something. 51, 2.8, okay. 51 and this is 18, no. 2.8, no, that will be less, I think. So it's a 6. No, it is less. Okay, so this does not work. So we can take log. So we will get some series where we have n going from 1 to whatever, I going from 1 to k log write it in a second row, maybe 2k minus 1 minus 2k. We have this series of negative terms, and oh right, so there is one more thing, right? That this thing, can we not convert it into factorials? Something like that. No? So we have this. So is this not like some factorials? So if you multiply, divide, then you get it from 99 factorial, and the denominator will become this thing square, and that will become 2 to the 100 times 50 factorial square becomes this. Now if you yes, but here you can use Stirling approximation, but when you try to prove it, it comes in this way only. So what is the and what is the Stirling approximation? It is by e to the n 2, 5, n. And yeah, but I do not know the difference. I don't remember the gap. Maybe you can look that because you need to know the gap for this inequality. And it will surely work, but then you have to prove the Stirling approximation. So yeah, but yeah, I understand. So it's yes, then there has to be a more elegant way to do it. Let's see. So, so there is this summation. So we need to check. You have to first check if x going to log 2x minus 1 minus log 2x. Is this an increasing function or not? Or- right, and then there'll be 2 here. Yeah, that's right. And this one is positive, right? So it's an increasing function. Okay, it's an increasing function. So then you know this result. It's good to recall it. So you know that this f1 up to fn, right? This thing, this summation would be less than some integral. um, so it is an increasing function. So if I just take the integral from 1 to n plus 1 maybe, right? Then it is less. And you can check that. So on. So when you say f of 1, you know these things. Yes. And this inequality actually can be quite useful. And in the exam, you can, of course, use it. So like this. And so this is f of 1 is the area of this first rectangle and so on. And because it is increasing, if you take the integral, then it's bigger. But you have to take the n plus 1 because this when n also is there. Yes, it's also seems to come up, right? And so you use this, and then on the other side, you have to use, I suppose, 0 to n. I don't know how you'll deal with the log with the 0, but suppose I suppose you can take care of that. Maybe you take some epsilon or something. Try using this. I think it should come. I mean, in the worst case, you can't. You've learned log, you've learned integration, so you've used this fine. But obviously, it's this is one to solve it. It's a separate thing that how to uh, get some elementary solution. That also you can keep thinking, but this will give you a solution. Right? Yes. And meanwhile, you can also try to look at the Stirling approximation and see how it is proved. Okay. Maybe on Wikipedia you can see, but try to prove it on your own. Try to do most of the steps on your own. There elementary, but since there's not much time, so you can proceed. Yeah, that's up to you. But knowing that approximation can also be useful. Yes. Okay. Okay. Mhm. endpoint lies within another of the drawn segment. And you are drawing several line segments, right? Finite number of line segments, right? So you have drawn, so it's like this. Yes, yes, yeah. I mean, that's what they're asking. Is probably not possible. Yeah, that's I don't know. Say that. Say the last maybe last part again. Yes, yeah, I understand. Yeah, yeah, but let me just confirm from the statement. So can you state the statement again? Mhm. I think it can. I mean, within is not a problem, right? It is not because if you just interpret within as a English statement, then it can be the two endpoint also. Otherwise, you have to say interior or something. Oh, right. But I think you are saying that because then it is possible. Right, right, yeah, exactly, exactly. So then you have to make two cases. You say that if I interpret in within as allowed to lie, then yeah, then this is solution, and otherwise this is trivial solution. Yes, exactly. Whatever you understand, then it's fine. Yeah, and then right, a good question. So then, if it is not in the interior, then you're saying that probably it is not possible. Sorry, if you're yes, if you ask it to be in the interior, then probably it's not possible. Right. I don't know. Yes, you have to think about it. It's a good, that's a good question. Yeah, maybe I'll think about it. Yes, 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 yes. And about yesterday's that continuity question, yeah, I don't know. I couldn't solve it. Whether yes, yes, but I did have a claim. Like so, you know that if that function, if you remember, functional equation, you remember that. So you we will see that if you assume that it is monotonic, then the limits exist at the endpoint, which is obvious, and then you can solve the problem. So then the question is: so we assume continuity. First. Assuming continuity, can you prove that the solution to that equation is monotonic? Okay, if that is true, then it is true. And it is just I don't. Yeah, I did not try it. I don't know how to do it. And I don't know if it is true or not. It could be, because it's continuous, and then it was because the only solution you had was, of course, monotonically decreasing. So it could be, I don't know. Yes. But there is no reason to discard it, even though the equation suggests that there's not enough information. But that is what catches my attention. I mean, about functional equations, because the equation somehow mysteriously encodes a lot of information. Right? Sometimes you know that very well. So solving so many functions. So I don't know. It's a curious. Yes, exactly. Yes, it's a curious thing whether it's monotonically decreasing or not. Okay, so it's a curious thing, but I don't know how to do it. But I think about it. Rather than I just like to think about it. So let's see. You can see. Yeah. Yes. So yeah. Yes. So continue. Yeah. If you like, we can be on Friday. If you think it's needed, and you can just Yes. Yeah. So you depends on your preparation amount. Right? You need to study and so on. So it's up to you. Yeah. Okay. So yeah, but keep in mind this thing. Don't get nervous and like whatever you do, just do right. Don't yeah yeah. It should not be that you should lose your creativity in the process. Then not good. Right. So okay. See you then. Bye.